All right, so today I'll talk about object-oriented programming in R. I guess the reason why I want to go over this is because as you work in R, you might encounter objects, okay? You might, pretty much everything in R, you can kind of just type the name of it. So any function, for example, the mean, you want to find the mean of something, you can just type in the word mean and it will show you how the mean is calculated in R. Now the mean is calculated in R via C code, so it doesn't tell you very much, okay? But any other functions, like for example, if you want to fit a linear model, you type out lm and it will spit out all the code for fitting a linear model. Now, probably at this point, maybe it's too much junk for you to parse through, but that's okay. You might, but as time goes on, you might encounter more things, and a lot of things are implemented using the object-oriented system in R. R has three kind of ways to implement object-oriented stuff. Almost everything is here. Let's talk about this. But almost everything is in their base object-oriented system S3. But then they also have S4 and reference class RC, which just have some special features. So I want to talk about those. You know, are you required to use object-oriented programming? No, but there are some times where setting things up as an object with its own methods will make your life, you know, just a little bit easier, okay? All right, so talking about object-oriented stuff, we have to talk about classes and methods, okay? So the class defines the behavior of objects. Sorry, this is I copied a lot of this from Hadley Wickham's site, so it's all his New Zealand spelling. So we define objects as certain classes, and then we define the actions that can be used by these classes or that these classes can take with their methods, okay? And you can create kind of relationships where one object is like the child of another class, and that new object will inherit the kind of the attributes of the parent object. Okay. So we've got again 3 systems. So S3 is the generic style of is their base form of object-oriented programming. Okay, it's a very casual system, so there's not a whole lot of rules. You can just kind of define classes as you go along, and it feels a little awkward, but it's okay, and it works. So pretty much all the base objects, base classes that exist in R are S3, whereas you know, only in certain packages do you have S4 and the other kind, reference class. Okay, so S4 is similar to S3, but it's more formal. You have to formally define the classes in S4 and formally define the methods. Okay, and then reference class, or RC, are special because they are what we call mutable. Okay, so most of the time in R, the style of programming is functional programming, in that the function and what happens inside a function only interact with the outside world via the arguments you give the function and the object that it returns. Okay, so most of the time functions only interact with the outside world via that way, the arguments and the object that's returned. With reference classes, you can modify objects within a function, and it modifies them on the outside world, okay? And so reference classes will make use of the kind of the super assignment, you know, the double less than, and then and it does some just a few things that are different from regular old R, okay? All right, and then there's not object-oriented, but then the base types, which we covered early on in this class, the things like the integer vector and the numeric vector and the character types. Okay, so those are the base types, but they all come together. Okay, there is a library called Prior, which gives you insights into the type of object-oriented design. That's if you're trying to look into all of this stuff. You don't have to, but there's no regular old commands in R that says, you know, what type of object-oriented system is being used here. Okay, but Prior allows you to do that. Okay, allows you to pry into the objects. Okay, so let's talk about base types. So we've covered this, but anyway, so base types, that they've been in R since the beginning, and they are hardly ever updated. We never really create new base types. I think the last real one was like in 2005. Okay, so that's 10 years ago, which is a very long time in computer world. And that the last time they implemented a new base type, and that was when they implemented S4 objects. Okay. Base types encompass functions, environments, and then the more exotic objects like names, calls, and promises. And you can determine an object's base type with the command type of. Okay. And then you can also ask, is it this type? But the commands are a little bit funny, right? So we can create a function, and we can say, what is the type of f? And it doesn't say it's a function, it says it's a closure, okay? But then you want to ask, is it a function? You say is function. So it just does some weird things like that, right? The command sum is what's called a built-in. Or if you ask what it is, it'll say built-in, but then you have to say, you know, what is it? It's a primitive function, okay? And so you say is.primitive, okay? These are all kind of just finer points. You're not going to be tested on this per se, okay? But it's kind of good to know so that you don't get confused when you use the commands type of and encounter these slightly maybe unexpected behaviors, okay? And then I think when I talked about type of, we have mode and storage mode. They're pretty much the same thing as asking type of, but they're made to be backwards compatible with S programs, which was the predecessor to R. Okay, a lot of the stuff for base types is written in C, so you're not going to really see the code behind it. Okay, and here's just more details on all of that stuff. Okay, but so S3 is probably the main object-oriented system in R, and it's you can if you use the library prior, you can just ask O-type for what type of object it is, but if you don't use that, you have to ask, is it an object? And it will say yes, and then you have to say, is it an S4 object? And then it will say no, or you can say, is it not an S4 object? Okay, but that's kind of a pain. Okay, so anyway, we can create a data frame, and a data frame, keep in mind, what is the base type of data frame? It's a list, right? It's a list with different vectors, and the vectors are all of the same length, okay? The only thing that makes a data frame special from a list really is that the vectors are the same length, and we apply dimensions to it to try kind of turn it into a two-dimensional structure. So that is implemented by making it a class, an S3 object. Okay. If we ask, so in this data frame we've got two columns really, X, which is 1 through 10, and the letters A through I. Okay, and we just say, what is it, and they'll say this is a base type, and so numeric vector is a base, but then when you do letters, it turns it into a factor, and so a factor is actually also an object. Okay, and that's why it gets, when you have it print out a data frame, it prints it in this two-dimensional structure. And that's because we've given the data frame object a special printing instruction. So normally when you ask it to print a list, it prints it out, double bracket 1 and all the contents of double bracket 1, and then double bracket 2, all the contents of double bracket 2. If a data frame is really just a list, you would expect it to print out that way. But because we've implemented it as an object, it has its own special print method that prints it out like a table, the way you expect, or the way that we're used to now seeing it. Okay. Okay, so methods in S3, methods are functions, and they're called generic functions. So, for example, we can look up the function mean, and if you just type in mean without giving it any commands, it'll print out how mean is programmed, and it says use method mean, which is not very helpful. But then with the package prior, we can use ftype, and it says it will first apply the S3 generic, and then if it doesn't find that, it'll use the generic form. Okay. And this is called method dispatch, just because there's when you call mean, it might try to do a few different things, and so it'll try to figure it out as such. Okay. So all right, some generics don't use this stuff because they're implemented in C, and they use C functions called dispatch group or dispatch evaluation. We don't really have to worry about that. Okay. So given a certain class, the job of S3 generic is to call the correct S3 method. Okay. So for example, if you ask for the mean of something and you give it the object that's in the date class, it's not going to apply, it's not going to run, because the way dates are stored, they're stored as integers after the date 1970 something, okay? It's like the number of days since 1970 something. And so if you were to just ask what's the mean of these numbers, of these things, and if it just applied the base function, it's just going to take the average of these numbers, and it'll give you some, it's been several thousand days since 1970 something. That's not useful to us. So when it receives an object that's of the date type, it will say, oh, you know what? I've got to run this command, okay? This function, mean.date. And then it will run that thing, okay? Or if you do print, right? When you print a factor, it prints out the letters. But we know that if you do the type of for a factor, it's actually integers, okay? So instead of printing out the underlying integers, what it's calling up is print.factor, which has special features in the program that will print out the factor the way you're accustomed to seeing. Okay, so anyway, this is how you program something, and so this is why in current kind of like modern style guides they discourage the use of a dot in function names, because print.factor is supposed to indicate this is the factor method for printing. Okay, so when you have something like print.dataframe, okay, I mean R knows what you're talking about, but it could be confused as is this the print method for .data frame, or is this the print.data method for frames? Okay, now we know it's not this and that it's this, but you know, that's why they discourage the use of the dot. Okay. So, you know, this is like transpose. T is the transpose function if you're going to apply it to a data frame and it knows it's a S3 method, whereas the command tTest is not transpose on a test object. It's tTest, okay? And F-type knows that this is the generic function, okay? Okay, and you can look up methods that exist for certain commands. So you can look up methods that exist for mean, and you get, you know, mean.date, mean default, mean difference time, and mean of these other things, okay? And then the method for tTest is you've got the default tTest and then a tTest that can be applied to formulas. And then if you give it some, so there's an object class called time series, TS, and then these are all of the methods, the generic methods that are applied to time series. So you can see that it has its own print function, so that if you print out a time series object, it prints in a very specific manner, okay? So if you've ever done any kind of data analysis with linear models, you know that when you run some linear model and then you just type out the thing, so you do model, store into model, lm, y as explained by x. If you type out the model, it prints out a very specific output, okay? Or if you run a t-test, it prints out a very specific output. And that's because they have modified the way print works for these things. And it's not the generic printing function. Okay? So we can define classes and objects very easily with S3, okay? You just say, here I want to make an object foo, okay? And then you put inside the structure, you're going to say it's going to come in class foo, okay? You don't even have to define it, okay? And here we're just giving it an empty list. And so this creates a new class called foo. And later on we can define all of the special things that foo gets, but that's that, okay? Or you can just say, here's an object foo, it's an empty list, and we're going to say the class of foo is its own special class, okay? It's just like, it works just like that, okay? And then later on you say, what is the class of foo? And it says, yeah, it's class foo, okay? And we could have named it whatever we want, okay? It doesn't have to be anything special. You can, if you wanted to turn class of foo into factor, you can write factor here, okay? And it'll turn it into a factor class, and it'll try to do its best to make it a factor, and maybe it can, maybe it can't, and it might return some errors if it can't, okay? But it just works kind of on the fly like that, okay? And then you also have these things of the class. You can also give it a vector of classes, okay? So for example, GLM object, which is a generalized linear model, its class is two things, GLM and LM, okay? Which means when you run a method here, what it does is it first looks for a method that's specific to GLM, and then if it can't find a method specific to GLM, it's going to find a method specific to LM. And if it can't find that, then it's going to run the generic method. Okay, so, and yeah, that's that. So, whether you use underscores or what's called camel case, I didn't realize that this was called camel case. That's up to you. All right, so a lot of times you have a constructor function which creates kind of like a new object of class foo, but it's not not always necessary, but usually usually you have one. So for example, if you're going to if you want to create a factor, you usually say factor and then parentheses whatever it is that you want to turn into a factor. Or if you want to create a data frame, you do data.frame parentheses whatever you want to turn into a data frame. Okay, and that's called the constructor, and usually it's the same name as the class that you're doing. Okay, so that way you say, you know, I want to create a class called foo, and then later on, if you want to make objects of class foo, then you'd say foo parentheses whatever it is that you're going to put into it that turns it into class foo object. Is this making sense? All of this object-oriented stuff? Okay, and I realize, you know, this is kind of the, you know, the nitty-gritty inner workings of a language, of R, which at the time may not seem super fascinating. However, I think it will be useful in your, I don't know, to become a more efficient programmer, okay? And, all right, so, you know, how far you get, I guess that's up to you. Okay, so, yeah, so it exists for factor and data frame, and there you have that, okay? Usually have the same name as the class itself. And so in this case, we're creating a thing foo, and all it does is it's just gonna, whatever you put into foo parentheses, it's gonna just create a list called class foo, and it just has to make sure that, here it's just trying to make sure that X is numeric here. Okay. But it has no checks for correctness. So here we're trying to, we fit a linear model. We just run lm, and we say lm data from motor trend cars, okay? And we can ask, you know, what's the class of this model that we just created? And it says the class is lm. And then if you print model, then it calls its own special print method, and it says and it prints it like this, okay? But we can, okay, and we can say, you know what? I want to turn the class of model into a data frame, okay? This is a bad idea in general, but you can do it, okay? And then R says, okay, sounds good to me. And then you say, you know, print model now, and it's like, okay, this is what I get, and you're like, oh, what happened to all the information? It's still there. It's just it doesn't know how to print it properly because you've changed the class. Okay. So, you know, you can still call model coefficients and it's still there. It's just it doesn't know how to print anymore because now it's calling the print data frame method rather than the print lm. Okay, and so that's why if you go to R, you can look up print, and it will have this, but you're like, oh, this isn't what I wanted. So if you want to see how a print lm works, of course it doesn't. There's no documentation for that. Okay, but certain things, so I guess there's no documentation for println, but you know, when you call the summary function, okay, so I think, you know, if you've never created a linear model, maybe this is unfamiliar to you, but if you ask for summary, it'll provide certain things, like you give it data and it'll summarize it, calculate the mean and the median. But then a common thing is to create a linear model, and then you say, give me the summary of that linear model. And what it's actually calling is summary.lm. Okay, and it will say summarizing linear model fits. It's calling the summary function method, or summary method, for the object lm. Okay. Okay, and so what it says is, yes, you can do stupid stuff like changing the class of an object to something that it shouldn't be, okay? And basically, R's not going to stop you, just you shouldn't do it, right? It says, what Hadley says is you can point the gun at your foot and pull the trigger, doesn't mean you should do it. Okay. So, if we create a new class of object, we can also create methods for it, okay? And so to create a new generic function, we create a function that calls use method, okay? And the use method takes two arguments, which is the name of the generic function and the argument to use for method dispatch, okay? Then, and if you omit the second argument, it will dispatch on the first argument of the function, okay? So there's no need to pass any of the arguments of the generic to use method, and you shouldn't do so, okay? And it says use method uses black magic, okay? So anyway, you just define some generic function f using use method, okay? And then you give it some methods, okay? You just create a regular function with the generic class. So this is, if you do f.a, okay, this is a function for class A, and then you just give it stuff like if you're gonna run f.a on something that has class A, all it's gonna do is return the class of A, okay? Or I'm sorry. So f.a is just going to print out class of A, okay? And so here we're writing and just creating a new object, and we're calling it class A, and we ask what's the class of A, and A is of class A, and then we say f of A, which is actually calling this version of the function, and it prints back class A. And we can create the version of mean.a, which is just going to print back quote A, okay? And we can say what's mean of A, and it prints back A. So it doesn't actually call the generic mean function, it just calls our own special method for A. And so again, it says there's no check to make sure that the method that returns the class compatible with the generic. So generally, when you run mean, it's going to return a numeric thing, but here you could have it return whatever you want. So you can just overwrite things and make things go crazy, and that's up to you. Okay, so method dispatch. Use method creates a vector of function names. Basically, it says generic with certain classes, and then finally default, okay? And so the default is what it falls back on if it doesn't find a method that's specific to a certain class, okay? So we've got function f, and that's going to be use method f, but then if we want a default version, which when we call f, what's it going to do if it doesn't find, so far we've only defined one for class A, and we can create one for default for everything else that doesn't have a specific function. And when that happens, it's just going to print back unknown class, okay? So here we give A something with class A, and it says class A, okay? Here we give it an object, and this object is a list with where the class is a vector, right? The class, so first f looks for a function or a method specific to class B. It doesn't find that, so then it goes to the next thing, and then it finds the method specific to class A. It finds that, and it prints it out, and it says class A, okay? But over here, we give it an object of class C. F looks through it, and it says, well, I didn't find anything with a method specific to class C. There's nothing else, so I'm going to fall back on the default class, and it's going to print back unknown class. Okay, so you can define methods for certain classes, and if you want just kind of the general one, you do f.default, or the function name .default, as you define the different methods. I feel like we can skip this slide. Okay, this is group generic methods. Basically, all of these things are called generic methods. All of, just your regular old base comparison operators and stuff. These are all generic things, so don't worry about them. They behave special. I don't think anyone's going to try to make a class-specific addition operator. So if you want to do that, then you can look up group generics. Okay. You can also, if you want to call a certain function for a certain class on something, you can call it. Okay. So again, if we create an object of class C and we call function f, where there was no class-specific method, normally it would look up just f.default, okay? And it would return unknown class. But if you wanted to, you can say, I want you to run the method specific to class A on an object that's class C. And if you do that, it'll say, okay, when I run that method, it says class A, all right? Again, not a good idea, but you can. Anyway, why would you want to do this? At some point, maybe if you're like trying to eke out little bits of efficiency, then you can do this, because technically it does require a few extra processing cycles to find the original function, figure out which method it's supposed to run, and then run that appropriate method. And you can just jump straight to the method that you want. But if you make a mistake, you can get yourself in trouble. Okay, so that's S3, and I'd say that's probably the primary bit that you've got to understand in terms of object-oriented programming in R, okay? It's kind of, it's a little bit loose, but you can do some good stuff with it. We have S4, which works similarly to S3, but it adds formality, and it only allows for certain things. You have to now have formal definitions which describe their fields and inheritance structures, and you say this is going to be this and this is going to be that, and then you have method dispatch can be based on multiple arguments rather than just one. And then you have a special operator, the @ sign, which is pretty much the same as the $sign, but it's specific to S4 things. Okay, so you've got the methods, which, okay, so the methods package is loaded automatically, but sometimes it's not. So if you're running things in batch mode, you got to call it manually. Okay, and we're just going to cover just a few things. Okay, so you can just to see, is it an S4 object? So none of the base objects in R are S4, but sometimes in some of the packages that you use, you'll have S4 objects, and you just use library prior and you say what object type is it, and it will say S4. Okay, so there is so we'll look at the stats4 package. And if you use maximum likelihood estimation, it creates an MLE object, and MLE is implemented as an S4 type, okay? So we say library stats4, we give it some data, we fit an MLE, okay, maximum likelihood object, okay, to this, and we can say, is it S4, the fit object, and it'll say yes, or we can use the library prior to say what's the object type of fit, which will say, which is an MLE object, it will say S4, okay? So there's nothing magical here, it's just in the stats4 library, they have designed MLE objects to be type S4. Okay, Yeah, the knobs is one of the arguments in MLE. Okay, so an S4 generic is knobs, and you ask what type it is, S4, and then generic. Okay. Blah blah blah. Okay. You can use is, and you just say, basically you're asking what is it, okay? And so what type of object is fit, and it will say it's an MLE object, or you can say is fit an MLE object, and that will also report back true, okay? With S4, the key difference here is you must define the representation of a class with set class, okay? So you have to say, so with S3 you could just be like, here's this, oh, let's call it foo, all right? We're creating a new object called class foo, and R goes, all right, I'll do it. Here you've got to, you have to define a class with set class and define the exact structure of the object, okay? And then you create new objects with new. So to define a class, you've got to give it a name, and then you've got slots, and then if it's going to inherit anything from another object, which you're going to call contains. Okay, so for example, we can create a person class, and maybe in this simple case, we're going to call it the two attributes of the person class, or not attributes, well, the two things in a person class is the name, which is going to be a character vector, and age, which is going to be a numeric vector. Okay, and and so we do this. Okay, so here we're going to create a class called person, which will have which is a list that says name and age. And then we're going to create a class called employee, and the slots that it has, additional slots will be boss, which will be a person class. Okay, and the employee also contains just regular old person. Okay, so Alice will be a person whose name is Alice and age is 40, whereas John is a employee class whose name is John, the age is 20, and his boss is Alice. Okay, so here we are just inheriting everything from the person class by using contains equal person, and then adding to that list, we're creating a boss field. Okay, but the boss field has to be of type person, or not type, of class person is what this says. So you have to define things with a little bit more structure with S4. You can't just do things on the fly. Okay, we can ask what's the age of Alice by using the @ sign. We can also use it with the $sign. There's really no distinction. Okay, and then or you can use double bracket notation or slot, and you say what's in the boss slot of the John object. Okay, and it says what's in the boss slot is an object of class person, and the name is Alice and the age is 40. Okay. Okay, and so we're going to create a new class called ranged numeric, which is the numeric, and in this slot we have a list which is just min to max. Okay, and you can just give it whatever stuff you want. So for example 1 through 10, but then you have to clearly say the min is 1 and the max is 10. Okay, there's nothing inherent about, I called this min, but it's not actually calling anything special. So when I call it ranged numeric, I could have put in any number here that I wanted. Okay, but it would just, the generic stuff that goes in here just goes under the data slot, okay? But, you know, the min, this value 1 that's in min goes into the min slot. Okay. All right. So anyway, what this slide says is you can redefine classes, but with S4 you're going to run into problems, because if you redefine a class and you have objects that were created under the old class, and then you try to use that new definition, it's gonna freak out with S4, okay? Whereas S3, it just kind of said, I'm gonna do my best. S4, it's gonna say, whoa, wait a second, this object that I have here doesn't actually look like this object. All right, so with S4, you create methods using set method, okay? And set generic, okay? So you set a generic for union, and then we're going to create a special method for union, and we're going to just make sure that it works with data frames, okay? And so when we do set method for union, we're going to say, hey, we got to make sure that X is a data frame and that Y is a data frame, okay? And you're going to do run this function rbind. Okay, and you can also, if you're going to create something from scratch, you just run the command standard generic, okay, which is the same thing as use method for S3. So use method S3 creates the generic version of F that we did at the beginning. Over here, now you do standard generic for S4 objects. Okay, anyway. Blah, blah, blah. You know what? I'm going to just skip to reference classes. I suspect that you probably won't do a whole lot of S4 programming in this class, but it should be there for completeness, okay? I want to talk about reference classes, which are a special case of S4, but I guess they become their own class, okay? And so the very interesting thing about reference class, or RC, is that they are mutable, okay? So usually R will create a copy of everything you do, but with reference classes, it doesn't happen, okay? So we're going to create just a new reference class, and it's going to be called an account, okay? So the idea is here we're going to have something that keeps track of like a bank account amount here, okay? So if we want to model a bank account, we can create a new reference class called account, all right? And then we just create, so whenever you create a reference class, there's going to be a generic or inherited kind of method, and you say account $new, and it's going to create a new new object here, okay? So, and in our reference class account, we're going to create one field, and that is going to be balance, and balance has to accept numeric type data. All right, and so here I'm creating a new account called A, and the balance is 100. So later on I ask, what's the balance in A? And it says $100, okay? And then I say, okay, let's update the balance in A, and that's going to be 200, and it says, okay, it's 200. So this part is totally normal, right? This part behaves exactly the way you might expect it to. But then here's where things change, okay? So here I'm going to create B, and I'm going to say A goes into B, all right? So normally with R, for every other object, this just creates a copy, okay? And so now B is a copy of A, and then, you know, if you modify B, it changes. But because A is a reference class, okay, it doesn't create a copy, okay? So if I ask, what's the balance in B, okay, it says 200, which is exactly what we expected because we said B is the same as A. However, look at this. If I change the balance in A to 0, and then I ask for the balance in B, because B is referencing A, it reports back 0. Okay, so with a reference class, you get mutable objects, meaning they, B references A and not, so it behaves a little bit differently. Okay, so you have, if you want to create a copy, then you have to use the copy method. Okay, so you say a $copy. Okay, so now A has a balance of 0, right? Okay, because we said A has a balance of 0. So here we create a copy, and then we ask what's the balance in C? 0. Okay, we can change A to 100, and now because C is a copy of A and not referencing A itself, it still reports 0 here. Okay, so this is reference classes are useful if you're trying to keep track of, like, I don't know, a certain state that is kind of shared across, I don't know, certain functions and stuff. Then a reference class object is useful. You can add additional methods. Okay, we can do withdrawal method and deposit method. Okay, and so notice to indicate that we're changing the balance in the reference class, we're using the super assignment character here. Okay, and so so then these things will modify the account. Okay, so for example, we're creating a new account with a balance of 100. Then I do deposit 100. Okay, and a $ balance is now 200. I didn't have to. So normally with regular old functions, you have to say A is going to take on A plus 100 or whatever, A balance plus 100. Now it just, the function itself modifies the stuff within A. Okay, so that's a huge difference with reference classes. Yeah, okay. I'll let you read this. This part is just some little bit more detailed stuff. I want to talk about kind of the upcoming week and next week and stuff. So I think we're going to start transitioning away from talking about R and all of the programming in R, and we're going to start moving into computational statistics, which is using the computer to answer difficult statistical questions. Okay, so questions that may not be able to be answered directly by mathematical methods, and using the computer, that's computational statistics. So our first entry into that will be with simulation. Okay, so simulation, I think, is a natural way to understand how to answer statistical questions using a computer. And so we'll take a look at that, and that should take us up through the content that will be covered on the midterm. So the midterm will cover kind of all of this stuff plus simulation. So we'll do that. Okay, so we'll see you guys on Wednesday.